Please welcome Michael.
Hello.
And please fill out the evaluation forms before the end. They're very helpful for us. Keep forgetting to say that.
Yeah, so hello everyone. My name is Michael Rash, as you mentioned. Thank you. This talk is going to focus around some of my open source work that I do in my free time, and in particular the projects that I release on cypherdyne.org are all open source, and you can download them for free, of course. And please, if you have any questions, feel free to interrupt me at any time. I'll try to look for you in view of the light there. So what I intend to cover briefly is basically what my vision is for Linux firewalling and how it can be a lot more effective than most people think when it comes to actually doing attack detection and in some cases response. We'll talk a little bit about Snort rule emulation with fwsnort. We'll talk about iptables log analysis. We'll discuss some iptables log visualizations, which are some interesting things that you can see in a graphical way that are derived from the parsing of iptables log information using two projects called Afterglow and GNUplot, which are both open source, of course. And we'll wrap up with Single Packet Authorization and a new release of fwknop 1.9.2, which I'm releasing here at Source Boston. And we'll wrap up with a live demo of that, assuming everything I got set up here correctly. We'll see. Incidentally, most of the themes that I'm talking about in this book are discussed, or in this talk I should say, are discussed at length in my new book published late last year. This is not a typical book about firewalling. It's very technical. It's designed to introduce you to how you can combine firewalling with essentially IDS technology at the same time. If you have any questions, don't hesitate to email me. Has anyone attended a talk I've given before at ShmooCon or DEF CON? No? Okay. There is some duplicate material. I will warn you up front, but I intend to change quite a bit around, especially when it comes to the single packet authorization talk. That is new material. So why should we be interested in intrusion detection in the context of iptables or firewalling in general? Well, there are lots of ways that IDSs themselves can be targeted, both from a code execution standpoint as well as forcing them to generate false positives. Think, for example, a modified stick or snot style attack against an IDS infrastructure, but instead of just sending spoofed TCP ACK packets with malicious looking patterns, you now modify these tools to run their attacks over Tor. Thank you, Roger. Also, the code execution standpoint, early last year, the Snort DCE RPC vulnerability was a code execution vulnerability in Snort. IDSs themselves can be targeted in some case, as we see. There's another older attack called the Witty Worm against ISS infrastructure. Security devices themselves can be targeted quite frequently, and therefore defense in depth is important. If there's another mechanism out there that can provide an additional angle for achieving better security, it's most likely a good idea to use it if you can. Also, an interesting consequence of using iptables to do IDS is that host fragment reassembly issues are less of a concern, and we'll talk a little bit more about that later. So what can we do with iptables from an IDS standpoint? Granular packet header tests are something that iptables, of course, has to be able to do to be able to effectively filter traffic. So we're just looking at transport layer characteristics and below here. It does connection tracking, which is a nice consequence because you can build in infrastructure within a translated Snort rule set that makes it difficult for someone to just send a plain vanilla stick or snot style attack against your iptables infrastructure to force it to generate false positives. iptables can be made immune by using net filter connection tracking to that particular attack. Incidentally, string matching in the Linux kernel with iptables started back in the 2.4 kernel series several years ago and was released underneath the Patchomatic project with NetFilter. That, unfortunately, did not carry through when they released the 2.6 kernel because there was a change made late in the 2.4 kernel development series to an internal data structure called an SK buff structure, or a socket buffer structure that's internal in the kernel. They made a change such that those SK buff structures could lie on non-contiguous memory, and the string match extension, at least the original incarnation of the string match extension, assumed that SK buff structures lied on contiguous memory, and that assumption was faulty as soon as they made that global change. Fortunately, after the string match extension was essentially broken all the way up until 2.6.14, Pablo, I see you, I don't know exactly how to say his last name, but he rewrote the string match extension in 2.6.14, and it has been available ever since. So if you're running a recent Linux kernel, you most likely already have actually string matching compiled in, because that was an enabled by default feature in NetFilter now. So not only did he rewrite the string match extension, he actually sort of rewrote it with a vengeance, you might say, and it supports now multiple pluggable algorithms. So you have a packet, which is a small piece of data, and you want to search for a needle in that packet. So an IDS signature, for example, looking for a particular pattern in that packet, you can select the algorithm that you want the kernel to apply to search for that needle in that haystack. Both the Boyer-Moore and the Knuth-Pratt-Morris algorithms are supported. Boyer-Moore being a very popular string matching algorithm in intrusion detection systems because it exhibits good performance characteristics. So another consequence of doing string matching within kernel space is that essentially when you combine string matching with NetFilter connection tracking, you get network layer defragmentation for free, at least as far as the kernel IP stack is concerned in Linux. So if you look at Snort, you can configure Snort to run the defragmentation algorithm of the associated targeted IP stack by using the frag3 preprocessor. The thing is, you have to associate that by IP address. In other words, you have to tell the frag3 preprocessor, okay, this IP address range is running Solaris machines. This IP address range is running Windows machines, and it will run those respective algorithms that you configured it to do when it sees an attack directed at those IP addresses or coming from those IP addresses. But what happens if your IT department and your security department have disconnect, and your IT department stands up a Linux machine in the range of IP addresses that's supposed to be reserved for Windows? Now all of a sudden you have Snort running a defragmentation algorithm that doesn't match the IP stack of the actual system on the network. So if you're running a host-level firewall on a Linux machine, you get this for free. You're actually running the defragmentation algorithm of the IP stack on the actual system, so you don't have to worry about that potential complexity if you're doing this kind of matching with IP tables. And that is, you combine a state tracking rule. That is necessary. And the reason that's necessary is because the kernel cannot classify a packet as a part of a connection in the NetFilter sense if it's a fragmented packet. It has to defragment it first in order to be able to do that. And intrusion prevention, I sort of hesitate to use that term. I think it's an overly used marketing term these days. Particularly when you've got really nice, complex usages of application layer encodings that are challenging IDSs and they can't really effectively stop things. And prevention seems like a strong term to me, but in some cases it can be legitimate. Think of a scenario where you have critical infrastructure deployed in your network that has a new vulnerability discovered. Let's say it's production DNS servers or something, and let's say the vendor hasn't created a patch yet, so there isn't a patch available yet. You can't just take those systems offline. They're critical infrastructure, so you, in that case, if you find an automated attack that doesn't bother to obfuscate how it's attacking a system, and there are many such examples of that because the target environment is generally so rich, then you may just say, I want the ability to control the shape of the application layer data that's entering into that production system. And for certain things that look malicious, I'll just say, I don't care about whether or not that's going to interfere with legitimate communications. I will define those packets as not worthy of communicating through the system. Anyone have any questions so far? Please interrupt if you do. So fwsnort, what is this? It's a GPL project. It translates Snort rules into equivalent iptables rules, and I have equivalent there in quotes because there are many differences. Essentially fwsnort tries to attempt to answer the question, what is the closest incarnation we can make of a Snort rule set, but put it directly within the Linux kernel itself. And you'll see that you can get fairly far considering how flexible and powerful iptables is. There are some features that fwsnort that are important. All fwsnort rules that are created are placed within dedicated chains so that they never interfere with your existing iptables policy. So you may ask, what's the translation rate? Well, we can get about 60% of all Snort 2.3.3 signatures translated into an iptables rule set. And I say Snort 2.3.3 because that was the last Snort release before the VRT licensing scheme was released, which is a proprietary licensing Snort rule set released by SourceFire, and so they're no longer released under the GPL. So things that we can emulate within fwsnort include the evaluation of the familiar home net and external net variables. There are some others in there as well, like HTTP servers and things of that nature. If we're talking about IDS, we have to have some reporting functionality. The log target in iptables provides that to some degree, and it integrates with another of my projects called psad. So we at least can generate events via the log target that are indicative of attacks, as long as fwsnort has told us when these packets contain things that look like Snort signatures within network traffic. Blacklists as well as whitelists are implemented. Blacklists are implemented via the drop or reject targets. If you define certain classes of traffic that you never want to enter into your network, you can either use the reject target to send an ICMP destination unreachable message for UDP traffic, or send a TCP reset for TCP traffic, or you could just use the drop target. And in one of the later releases of fwsnort, the Snort signature information itself is placed directly within the kernel as well, within the comment match. So if any of you run iptables and you use the comment match, which allows you to put essentially a piece of text within the iptables rule set itself, so that when you list those rules, you get a little tag that tells you what those rules are about. fwsnort uses that to include things like the Snort message field and some other information. And finally, the nice consequence of using iptables is that it's inline by definition. We have a really well-tested piece of inline infrastructure in the Linux kernel. So if you run proprietary intrusion detection systems that offer an IPS mode, commonly there are bugs in those infrastructures because they're not easy to develop. But iptables provides a robust inline mechanism for inspecting network traffic. The Linux kernel, as you know, has huge numbers of downloads. There's all sorts of testing. The development pace for NetFilter is extremely fast. So when bugs are found, they are generally fixed extremely quickly. So psad is an iptables log analyzer. It's not enough just to have events generated by fwsnort. You also need to have infrastructure that can parse iptables log messages, because iptables itself has the interesting things to say within its logs. This offers email and syslog reporting so far. Other infrastructures will be added soon. And it integrates with fwsnort. DShield, I think, is a really interesting project out there. It's a distributed intrusion detection system. For those, you probably heard of it. psad can send logs that come from fwsnort or from iptables and send them off to DShield for you. It's a really nice global view of being able to get some data on IP addresses that are currently attacking various systems around the internet. You essentially have people that say, I've got logs coming from my checkpoint firewall, I've got logs coming from Cisco, let me go ahead and send those off to DShield, where it will do the analysis of those things to look for things like the latest attacks coming across from malware and things of that nature. It has an iptables log visualization mode, which I'll cover in a little bit. which integrates with both Afterglow and GNU plot. One of the more interesting features probably is and this is really derived from the completeness of the iptables logging format. POF, anyone familiar with POF, the passive OS fingerprinter? I'm sure many of you are. POF runs libpcap over SYN packets, SYNAC packets, and reset packets in order to try to tell what TCP stack generated those packets. It turns out that psad can do the exact same thing. It runs the exact same algorithm that POF runs over network traffic, but it doesn't need to sniff the wire promiscuously because the iptables logging format is so complete that everything that POF looks for, namely the don't fragment bit, the TTL value, TCP options, and a few other things, all of those pieces of information are included within iptables logs. So psad can do the exact same algorithm over just the log information. In some cases, the Snort signature set contains, I think it's about 150 signatures that do not require any application layer tests whatsoever. And in those cases, the iptables logging format, again, is so complete, generally, that psad can run the same detection mechanisms over those log messages that Snort would, in those cases where application layer tests are not required. It offers detection of many of the port scan types generated by nmap. You can run psad in a more active mode, so timeout-based auto-blocking of IP addresses is offered, and that can also be integrated with fwsnort, which allows psad to only block IP addresses that have been tied to the communication of malicious application layer data over established TCP connections. You don't want generally to enable any sort of auto-response mechanism, particularly for things like port scans, which are so easily spoofed from arbitrary IP addresses. So, packet flow, quickly. Generally, so fwsnort interfaces with the filter table in iptables. And the three boxes in red represent the three default chains that are available in the filter table. So you have the input and output chains in the middle of the picture there are always apply to local socket communications that the kernel is making possible for the local system, whereas the forward chain applies to packets that are destined through the system after a routing calculation is made. Notice that NetFilter, of course, integrates with the IP stack, and the hooks are at a point where the routing calculation is already made in order to be able to do this type of filtering. So iptables essentially knows exactly after a routing calculation is made whether or not an individual packet is destined for a local socket or is destined through the system to a totally different system. So in fwsnort, how we integrate here is done via custom chains, and these two red boxes on the left-hand side show the fwsnort forward estab chain and the fwsnort forward chain. Any signature in Snort that requires a stream match, such that which restricts Snort to only triggering an event if that signature is detected in an established TCP connection. The fwsnort forward estab chain essentially emulates that by interfacing also with the iptables connection tracking mechanism. And then if you do decide to either whitelist or blacklist traffic, those operations are done very, very early within the fwsnort chain, and in an effort to minimize the amount of CPU cycles that it has to consume for those classes of traffic. So an example rule, this is an example Snort rule that's designed to try to detect when somebody may be trying to execute the nmap scanner through your web server. Kind of an interesting sort of generic signature there. And after it's translated by fwsnort, this is what the iptables command looks like. So let me go back here for a second. Just to notice, the flow keyword says that this signature should only trigger if the destination is towards the server in the established, and the session's in the established state, and the content is this nmap %20, which is the URL encoded version of the space character. So in iptables, this looks like the following command, a little bit complicated. It's probably not something you want to type in yourself. That's where fwsnort comes in, because all those commands are automatically generated. You can see the usage here of the comment match to include the snort message field, the class type, and also the fwsnort revision number within the iptables rule. And notice at the end, we're using the log extension to generate a logging message. We're not doing any other kind of interaction with this traffic. We'll go ahead and let it through, but we'll detect the attempt. And the way to read this prefix is the bracket 1 means that it's the first rule in that chain, which is the fwsnort forward established chain. It applies to snort rule ID 1361, and the established chain is a further piece of information that shows you that it was generated in an established TCP connection. Okay, I'm going to try to watch my time here, make sure I get through all of this. So here's another snort signature. This one is interesting because there are two content matches. iptables in, I believe, 1.3.1, which is released in a couple of years ago now, offers the ability to do multiple matches in the iptables sense. So you can sort of overload that in a sense and look for multiple content strings within network traffic with fwsnort. So any snort signature that uses multiple content matches can be expressed within an iptables rule. And here again is the fwsnort signature. Notice the usage of hex bytes. I added a patch to iptables to use the same syntax that snort rules do that allow you to include those hex bytes within those vertical pipe characters verbatim. You don't have to go through an extra translation step like you used to have to do with the original string match extension. So you might ask, well, snort has an awful lot of keywords, right? I mean, how many can we actually support within fwsnort? And generally the answer is anything that uses snort rule header options is something that can be expressed, things like looking for ports and protocols, IP addresses. The content keyword is supported. Flow is supported, which is an important one. And the remainder that you see here, not all of them are supported necessarily within a kernel that you have compiled. The TTL match is necessary to get, for example, the ability to look for specific TTL values that is, filter on them and log specific ones, even though the TTL value is included by default in iptables log headers, message headers. Unsupported options, and this is part of the reason that fwsnort can't completely characterize the snort rule set. And up at the top there is probably the most important one in my mind. PCREs are, if you look at the trend, are becoming more and more important within snort rule sets, because essentially what it gives you is a little dedicated decoder that you can use to express how an application will either respond to an attack or what the attack itself might look like. And it's very difficult to express that within an iptables rule because we don't have a PCRE engine directly in the kernel. There are certain pathological cases where you can construct a PCRE and data against that PCRE such that the runtime blows up into the thousands of years, and we don't want to make it easy for someone to crash the kernel just by wafting a maliciously constructed piece of information past the interface. So, but if any of you are interested in putting the PCRE engine into the kernel, I'd love to talk to you. The byte test and byte jump options are interesting snort rule options, and these actually will be supported within fwsnort to some degree because the U32 module was just recently added to the 2.6 kernel development series. I think it's in 2.6.24 now. So some support for byte test and byte jump will be added to fwsnort. And there are a few additional ones here that we can't filter on directly within an iptables rule, but in many cases they're included within an iptables logging message. So let's shift gears a little bit and look at some iptables logs and what we can see in them. So we'll look at standard TCP, UDP, and ICMP logs. And here's a canonical logging message for a TCP packet logged by fwsnort. You can see it up at the top there This was logged by rule number 199 in the chain. Incidentally, your fwsnort rule sets can become kind of large. I've run rule sets that have pushed 6,000. But the kernel generally handles that fairly well, I would say, owing, I think, to the strong development pace and ability of the kernel developers. And you can see that nearly every interesting field in both the network layer and the transport layer headers is logged, including at the end the options portion of the TCP header, and this is critical for doing passive OS fingerprinting. So graphically, all the dark gray boxes are fields that are logged by default by iptables and are not influenced. That is, you can't pass a command line argument to iptables that will influence how it logs these fields. You get these by default whether you like it or not. The gray field at the bottom, the options field for TCP, I'm sorry, this is for IP. This is for the IP header. IP options are also logged, but only if you use the -- log IP options command line argument to the iptables command when you're building your logging rule. And similarly, for the TCP header, you get all the dark gray boxes by default, source and destination ports, TCP window size, and a few other things. But you also can even log sequence and acknowledgement numbers if you like, as well as, most importantly in my mind, the options portion of the TCP header. So passive OS fingerprinting, at least the POF incarnation of it, requires the ability to look at initial TTL values, or that is an approximation of what you think the initial TTL was by the time you actually saw the packet, TCP window size, a don't fragment bit, the SYN packet size, and you need the entire TCP options portion of the header. So if we look at a TCP packet and then take that log message that's generated by iptables and try to figure out what TCP stack generated that packet, you can see POF tells us there at the end that POF signature off in the lower right says that this is most likely Linux 268 or newer, because this logging message matched the signature on the lower left, which looks for a relationship between the TCP window size and the maximum segment size and a few other things. Incidentally, I'm adding support in psad for also using the Ettercap fingerprinting database, which is quite a bit larger than POF. So Ettercap, I think, currently has about 1,500 passive OS fingerprints, whereas POF is quite a bit lower than that. So psad will run essentially both algorithms at the same, in parallel. Well, not really in parallel, it's Perl, but it'll run both algorithms across a TCP packet, so you'll get both fingerprints, and you can compare them. UDP, similarly, there aren't really actually there aren't any options that you can specify on an iptables command line to influence how iptables logs the UDP header. You always get just source destination ports and the length value. ICMP, sample ICMP message, ICMP type 8 code to 0, I believe that's ICMP echo request, ICMP ID value and the sequence value, and you do get some differences. The log target logs ICMP data slightly differently depending upon what the data portion of an ICMP packet looks like, and that is variable, and it depends on the ICMP type and code values. Okay, let's talk about something a little bit more fun. So there really aren't many good sources of really interesting iptables log data, with one really great exception, and that is the Honeynet project. And their scan challenges provide, in some cases, iptables log data for compromised Honeynets. And so it's a really interesting operation to take that data and then point psad at it or some other log analyzer and see what you can see. So the Honeynet project releases several things. They generally release iptables log data in some cases. They release Snort logs. They release even raw PCAPs, and also in some cases Apache logs for compromised systems. And they say, okay, here we had a compromised Honeynet tell us what happened, and it's a great exercise for the security community because it's a great way to educate yourself about what an actual attack actually looked like from the security tool perspective or log data perspectives. So scan number 34, if you're interested, contains 39 megabytes worth of iptables log data that shows some really interesting things, everything from port scans to port sweeps, although I would say port scans are not really that interesting these days, and traffic from worms, as well as outright compromises of Honeynet systems. And psad can parse that log information and then interface with, in this case, GNU plot. We're going to show, out of all of that 39 megabytes worth of data, what was the top port sweeper. We're looking for port sweeps, so we're looking at, in this case, the source is not coming from the Honeynet. In other words, it's an external source because the Honeynet addresses are 11.11/16. And we're going to graph in 3 dimensions the destination port versus the count as well. And that graph looks like this. There's one very nice outlier off in sort of the top left-hand part. And mapping that back into an IP address, which is a little bit of a laborious process, but we see that the IP address 200.216.205.189 was the top port sweeper out of that entire data set. And what is that IP address sweeping for? Looking for destination port 3306, which is commonly used for MySQL communications. That's one visualization. Moving to other types of visualizations, here's one with the Afterglow project, which generates link graphs. So here's the psad command that you would use in order to generate outbound connections from the Honeynet. So the Honeynet is deliberately set up in order to invite, essentially, compromises, because that's what we're trying to research. And if a system has been compromised on the Honeynet, outbound connections that are not associated with administrative traffic are very suspicious. So looking for outbound connections from the Honeynet is a good way to, in itself, of looking for things that you might want to investigate further because they might be indications of actual system compromises. So here's a graph over that same data set, a link graph. And what you can see is, the way to interpret this is all the yellow ovals are associated with Honeynet addresses. All of the red rectangles are associated with external addresses. And all of the blue ovals are port numbers. And the graph is a little bit hard to read, but off on the lower left-hand side, you can see that that yellow oval made an awful lot of outbound connections to other IP addresses. And looking at the port values, which you can't really see here, but there's IRC and there's also outbound SSH connections. So that would be a really good IP address on the Honeynet to investigate further. So I'm going to move this along a little bit here. This is a visualization of the Nachi worm, which sends a 92-byte ICMP packet. Of course, the length of the packet is characterized within an iptables log message, so you can easily look for it. And here you can see all the red ovals ganging up on the yellow rectangles, so you can see those essentially indicative of Nachi worm communications. So if you're interested in getting really good iptables log information, please use the following command line arguments. Use log IP options to get the options portion of the IP header. TCP sequence numbers, if you like. That can be a little bit of a security risk because you're essentially including in your logs how your TCP stack is generating TCP sequence numbers. Not usually too bad of a problem, but it can be interesting to look at sometimes. And log TCP options, again, is probably the most important in my mind because of the passive OS fingerprinting operation. Incidentally, I'll make these slides available on cypher9.org as soon as the talk is over in case you want to download them and use the commands. OK, so let's switch gears again here, and I'll try to get to the demo. So passive authorization is a concept that I'm particularly interested in. The basic idea is to combine a default drop packet filter with a passive mechanism for collecting enough data such that an IP address can convince you that someone has information that should be worthy of further communications. The idea is every function that's available to an arbitrary IP address has a non-zero probability of containing a security vulnerability. Not a very high probability on average, of course, but nonetheless a non-zero probability. What I want to do is minimize the number of functions that an arbitrary IP can communicate with. This is not security through obscurity. This is concealment in the same spirit as passwords and encryption keys themselves. So the first iteration of this concept is called port knocking. I'm sure many of you have heard of it. It uses purely packet header information to transmit that essential bits of information that allow the port knocking server to authenticate you. But there are some serious protocol limitations in port knocking. Namely, it's very difficult to protect against replay attacks. And there's a few other things here listed, such as it's trivial to bust a port knocking sequence en route just by spoofing in a duplicate packet to the last port that you just saw and convince the port knocking server that you really don't know the right sequence. And it's, being able to issue such an attack is really quite trivial if you can monitor any of the traffic between the client and server. Single packet authorization, you can think of it as next generation port knocking. It is implemented by fwknop and uses purely application layer data to transmit authentication information. And incidentally, authentication and authorization are not the same thing, but it does both. It solves many of the limitations in port knocking, namely replay attacks are very difficult to, very easily thwarted with single packet authorization. Asymmetric ciphers generally use larger key sizes than symmetric ones, well, sort of on average, I guess. And because we're using application layer data, you can actually, I generally use 2048-bit GNU PG keys for my SPA packets. And it only requires a single packet, of course, which means that IDSs don't generate alarm bells because port knocking sequences look like port scans, but single packet authorization messages generally don't. So fwknop today, what does it offer? Server support now is offered on Linux, Mac OS X, and FreeBSD. That is any system that can run iptables or the IPFW firewall. The client has been ported to several operating systems, and there's also a UI developed by Sean Grevin that's written in Delphi. There's also a Java one on the way. SPA packets are encrypted via Rindal or an asymmetric algorithm supported by GNU PG, and also probably in one of the more recent versions, 1.9.0, DNAT support now is offered. So you can actually, and I'll try to demonstrate this in a moment, you'll be able to, you can use that to allow your fwknop server to essentially act as a router, and after receiving an appropriate SPA packet on an external interface, it'll automatically build your iptables DNAT rules to forward an attempted SSH connection onto an internal system that you specify. So fwknop 1.9.2 is the release here at the conference. Here are some of the new features that are released in this in fwknop 1.9.2. Client-derived firewall access timeouts, so that you can specify as the SPA packet generator how long you would like those firewall rules to be kept open. Generally, it was implemented as a timeout mechanism before, but now fwknop offers both. There's an interesting prefix that the crypt Rindal Perl module tags to encrypted SPA data in Rindal mode, namely this salted underscore prefix. And so you could easily write a snort rule, for example, that would look for that salted prefix in order to try to detect if someone's actually using fwknop on your network. That has been removed because we don't really need it. So now you can just say, oh, I see fwknop 1.9.1 and below. And a few other things here. Also, I'd like to acknowledge there's a team of students in India that's contributing code into fwknop now, and they're advised by advisors at CalSoft, and they've contributed many of the features in fwknop 1.9.2. Just graphically, these DNAT rules, essentially what you are on the left-hand side, if you're running fwknop as a client, you can generate an SPA packet, and the idea is you want to get all the way over here into this SSH server, but you don't want to have to log into the firewall first, which generally shouldn't really be running an SSH daemon, perhaps. But nevertheless, you want the firewall to construct a valid set of rules that allow you to have a forwarded connection on through into that internal SSH server, and that is something that I will attempt to demonstrate. So just real quickly, future work. I think probably the most interesting one, two of the most interesting features here are a web proxy that will allow people to connect to an SSL-based web server with nothing but a browser, and then have that web server generate an SPA packet on that person's behalf, and also integrating a Firefox extension to generate SPA packets itself. fwknop is open source. Please submit patches if you're a developer. So live demonstration. Okay, let me switch gears here a little bit. I don't know if this... Can you all see that? Okay. So what I'm running here is I've got FreeBSD running in VMware in this window. And I've got so my Linux laptop is acting essentially as a router. And I have this little Linksys router here is running OpenWRT, which is an embedded Linux distribution for routers. There's an SSH server running on this system. And what I'm going to attempt to do, if everything is set up here correctly, is I'm going to attempt to communicate from the FreeBSD instance an SPA packet to my Linux host and request access through the Linux host via DNAT rules to the SSH server running on the Linksys router. So before I do that, I'm going to tell it to create DNAT rules on port 5001 to forward an SSH connection internally to the router. First, let me just show you ISengard is the host name that I'm using. It's 172.16.241.1. You can see if I try to telnet to that port, I don't get a response back because the iptables is currently in a default drop stance against that port. And now, if everything works correctly, let me put this up here. What we're doing here in this window is watching every second for the iptables rules that fwknop will create in the fwknop chains. And I'm going to put this window on top. And now I'm going to attempt to... So here's the fwknop command line. The most important feature here is right here, -- forward access 192.168.1.1 is the router IP internal to my Linux system, and I want to have it forward port 5001 internally to port 22, which with the SSH daemon running internally. So, as you can see here, it's created my DNAT rules. If I SSH now to port 5001, I'm now logged into the Linksys router internally. No access, no input chain access is involved here at all. This is all via the forward and forward chains and the NAT table and IP tables. And here momentarily you will see at the same time that fwknop has removed the original rules that allowed my connection to be established. But if I go back to my other window, I still have my connection established. That's because I'm using the iptable state tracking rule to keep that session established. I just can't establish a new one because there's no accept rule for an inbound send packet to that port anymore. But it's totally up to me when I'd like to log out. The session won't end until I do. So now I'll log out. And if I attempt to SSH in again, of course, I can't because those rules have been deleted. So I think I'm just about out of time. And does anyone have any questions? In that case, thank you very much.
Please don't forget to fill out your evaluation forms, and there's going to be a snack break around the corner in about 8 minutes. Yay, food. And if you want on the way out, just put the evaluation forms on the back table, that'd be great.
It's hot.
It's set pretty damn well, actually. You see on your, yeah. No, not yet. Yeah, it's set to cool, but there's just.
Thanks. I wasn't sure what the level should be, but hopefully it was all right.
Yeah, it's good.
Can you do fwsnort on the OpenWRT?
I haven't tried that yet.
Okay.
The most, I think so far the barriers to getting things working on OpenWRT are getting necessary Perl module support to run. So like Perl itself runs, but getting like module dependencies to also run is a different story because not all of the CPM models have been converted over to be able to run on OpenWRT. So working on that.
Okay.
But it should, once those modules run, and considering that Perl already runs, it shouldn't be hard. It's just a matter. It may be a matter of recompiling the kernel to include stream matching support if they didn't already include it. I haven't looked at that yet, but it should be possible.
Okay. Can you use psad for visualization and run it against like a TCP dump file?
Not yet. That's
Okay.
I think that's on the to-do list. That's a great idea.
See, most of my background's actually on the Windows side, so while I love a lot of the tools, I can't always use them on a day-to-day basis.
Right.
So, especially the log visualization part would be really useful. Otherwise, I'd end up booting up Linux systems just for certain tasks.
That's a great suggestion. I think if it's not on the to-do list, I'll put it on there and put your name associated with it if you want to email me.
Yeah, sure, no problem.
But that's definitely a good idea. I'd like to get to that point.
Yeah, I'm reading your book right now, actually.
Oh, great.
I want to get.
Oh, thanks. Let me know if you have any questions.
We'll do. Thanks.
Thank you.
Neo?
I didn't hear the full answer
I'm at
for
Neo,
FW
actually
Snort
interning
on
there.
OpenWRT.
Oh, right.
I think it's considered the Perl modules. Haven't yet.
Are you out of Boston?
Yeah, that's
okay?
that's generally the hardest thing.
Yeah,
like,
one of the Chicago guys,
so
Mike told me
Perl
about the
runs
conference.
on open. So I'm actually just getting started with that.
Oh, you have?
WRT,
Oh, I can
so-
write it
Okay,
for
so I
you.
know.
Oh, you have?
Yeah.
Oh, good.
Yeah.
Well, so I guess what I've seen, like Perl will run,
Yeah.
but I've looked for like some of the modules that FWSnort depends on. Those don't run yet. So, I mean, if you port those things,
Oh,
I mean, yeah, you email me or whatever. I mean, that as soon as those modules run, then it should be possible to get FWSnort to run too. The other slight dependency will be
I know what that's like.
to make sure that stream matching support is in the kernel, and I don't know if they've taken that out, perhaps, but that's one thing.
I know they are doing an overhaul.
They are, okay.
Yeah, so I'm just gonna try and get in there and take a look, but I couldn't help but thinking of it. I heard him ask, and I was like, yeah.
Yeah,
Good.
I'm working on that. I definitely would. I'm going to try to get all three of the projects to run on WRT.
That'd be pretty sweet. So, yeah. All right, cool.
Thanks.
Yeah, thanks.
or can you just fill these out later and like?
If you want to fill it off and leave it at the registration desk later, that's fine.
Yeah, that'll be easier than.
I would just write down the talk name so you don't forget. You'll end up with a stack.
No worries there. Yeah, I didn't see your ShmooCon talk. I wasn't there. Well, they put them up, so I was actually watching it 2 weeks ago.
Oh, really? Oh. Well, I'm sorry there was some duplicate material.
Quite
there.
okay.
There's I tried to maybe make this talk a little bit more polished than what it was in the ShmooCon talk, but I don't know.
Well, it's interesting. There's actually a security competition, college and cyber defense competition, defend only. College students basically go in and defend a whole bunch of OSs, servers, services, etc. So that's why, depending my tool set's often somewhat limited, we actually end up running most of things surprisingly on Windows.
Really?
Actually. And their port scan detection is actually very useful. I have custom Snort rules written for port scan detection tied in with Snort SAM. I don't know if you're.
Oh yeah.
Yeah. And then I wrote a custom plugin for Snort SAM to work with IPFW.
Oh, great.
Support for BSC's firewall over to Windows to block.
Oh yeah.
Protect our boxes.
Oh, that's very cool.
So it's very nice, but I'd love to be able to integrate that with the SAD and especially the visualization, because that's really where we found the harder part. I mean, part of it, yeah, I can look at my store logs and yeah, my SQL databases, but having the ability to do visual log tracking,
Yeah.
really nice.
Yeah. Well, that's a great suggestion. Maybe one of these days it'll do.
Yeah. How much hacking have you done with OpenWRT?
Not much. I just started actually.
Okay.
I've had people request GitHub be not working there, and so I started.
I find them to be amazing. Background is Windows, but I now know most of my Linux skills from managing and administering OpenWRT.
Really?
Because you can get them to do just about anything. Mine at home is running Bind for my DNS, it's running OpenVPN for VPNing between my apartment and then the family's house.
Wow.
Of course, iptables fully.
Wow, that's great.
Everything. So they're really nice devices, and for the price, the features, they're amazing.
Yeah. What device do you use?
I actually have a hand. By now, I think I own 5 of them.
Oh my gosh.
My primary is the older GS because it has a bit of extra RAM than the current GLs. The rest are all GLs or equivalents. The ones I'm actually getting in, Fawn, I'm not sure if you're familiar with them. Like, they're basically, their premise is on sharing Wi-Fi. So they sell routers and they're split, so you have an open, publicly accessible, and private network part to it. But actually, back in the day, like 2 years ago, they had a promotion to subsidize routers, and those were the WRTs. So that's where I got a few from. But they're doing the same thing. You have to have someone send you an invite, but then the device ends up being $11 or $13 with an extra antenna. The router is like that big.
Wow.
And it'll do OpenWRT, and it has an Athos chipset. So recently, people have been doing wireless injection attacks on Backtrack, all sorts of really interesting stuff.
Very interesting.
It's pretty cool. I have a few coming in, and I think of a lot of uses for things like that.
Yeah.
I'm really interested in the embedded space precisely because you don't always have the ability to drop in a full-fledged Linux box or those places where you want to be able to have something that's just small. Like I'm actually working on doing some inline stuff with OpenWRT, so hey, you can just drop it in and then have it dump everything to external drive or
Yeah, absolutely. That's great. I'm just getting a few with them actually. So.
But Open is great that way. I'm still using the older White Russian rather than Kamikaze.
Okay.
Mostly because
I had that on here.
Yeah, Kamikaze, at least the last one I was looking at, didn't have as much support or everything on it. So I'll probably upgrade it a bit. But otherwise, I mean, they don't have the most performance out there, but as far as ability, they can do almost everything.
Yeah.
And for the price, you can't beat it.
Yeah, that's awesome. Great. Well,
I'll give you my card. If you've got anything with questions like for OpenWRT that I can do.
yeah, thank you very much. What is your name? Jolly. Hi, Jolly. Hi, nice to meet you.
My pleasure.
I'll give my card too. This is my work card.
Yeah, I actually just texted one of my team members going, yeah, I'm in the guy's talk for the book you're reading right now.
Oh, really?
So, well, he does my Linux stuff for the competition, so I passed him, he looks at it, all right, you deal with this, I'll read it when I have time.
Oh, cool.
All right,
Great.
thanks.
Good to meet you.
My pleasure.